Alright, so we are going to be starting chapter 9, which is systems of equations, and we're specifically doing 9.1, which is the graphing method. So this section is still involving graphing. So if you have not already done so, which I thought I was pretty strict, but you need to make sure that you have some sort of graphing paper, whether it's the grid like I have here on OneNote, or whether it's actual graph paper. This is very important when you have to be very accurate and precise. So you have to use it, one or the other, okay? So system of equations, we're going to explain kind of what they are, some, things about them. So system of equations, two or more equations in the same variables. We usually see x and y equations, but again, you could have other variables, but typically when you use the systems, you use x and y, especially when you involve graphing. To solve a system of equations, you must find all ordered pairs that make all equations true. So you need to find all the solutions that make it true. We can find this common point of intersection by graphing both lines. So that's what we're going to do here. So for our first example, it says solve the system by graphing. So you have two equations. We need to graph them and see where they intersect to find their common point. That means that they both use that same point, which means that point is a solution for both of them, which is how you solve the system by graphing. Okay? So we're going to find out. So I'm going to negative 2x. Gives me negative y equals negative 2x plus 8. Divide by negative 1. So y equals 2x minus 8. Okay? So that's my first equation. And my second one is going to subtract x. So we get y equals negative x plus 1. So now I'm going to graph my equations. You have to be very precise on this because you need to see where they cross. So you're going to want to be as accurate as possible, as well as plot as many points as possible. The more points, the better. So I'm going to first plot my blue one, which is a y-intercept of negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. So that's negative 8. And a slope of 2, so that means rise 2 over 1. Rise 2 over 1, rise 2 over 1, oops, rise 2 over 1, rise 2 over 1, rise 2 over 1, rise 2. Okay, so I'm going to want to be as accurate as possible with my line, with my points, because I need to see where they cross, and I need to know that exact point. So I graphed that. Now I'm going to graph the red one, which it has a y-intercept of 1. And it has a slope of negative 1. That can be seen as negative 1 over 1, or that's also 1 over negative 1, okay? So I can do a rise of negative 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And lucky for us, I could kind of stop there because look, I already found where they cross. They cross at this point right here, which is 3, negative 2. So 3, negative 2 would be my answer because it's where they intersect. If you wanted to double check that it worked, I'm just going to do it for this one. I'm going to plug into the original two equations right here. 3 is my x and negative 2 is my y, and see if it makes the statement true. So 2 times 3 minus a negative 2 equals 8. Well, that's 6 plus 2 equals 8, which is true. If I do the other one, that's going to be 3 plus a negative 2 equals 1. Well, that is true. So therefore, that is confirmed that it's my solution. So that's my answer right here. This one right here, okay? Now we're going to try another one. I don't know why that is there, but okay. Let me erase it. There we go. Solve the system by graphing. Again, we need to change it to y equals mx plus b so we can graph them. So we have subtracting x. So we have negative 2y equals negative x minus 6. Divided by negative 2. So that is y equals 1/2 x plus 3. So that's my first equation. Second equation, subtract x. Negative 2y equals negative x plus 2 divided by negative 2. So y equals 1/2 x minus 1. So now I'm going to plot them. I'm going to plot the red one first, which is a y-intercept of 3. So I'm going to go up 3. And then rise 1 over 2. Rise 1 over 2. Rise 1 over 2. Rise 1 over 2. I'm actually going to do rise of a negative 1 and then run of a negative 2, so I can go both ways, so I can have as many points as possible. And I'm going to try to make a straight line. Okay. Then I'm going to graph the blue one, which is y-intercept of negative 1, and then rise 1 over 2, rise 1 over 2, rise 1 over 2, rise 1 over 2. And if I draw this graph, again, my lines aren't perfect, but hopefully you can see that they're parallel. They're never going to cross. If you noticed, they have the same slope. Same slope means parallel. Means parallel lines. Therefore, when do they cross? Never. Therefore, they have no solution for solving the system of equations. Because when we solve system of equations, we need to know where they intersect, where they have the same solution. But they're never going to, so they're not going to have a solution for this. And last one. So again, do the same thing. Change into y equals mx plus b. So subtract 2x, subtract 2x. 3y equals negative 2x plus 6 divided by 3. So y equals negative 2/3 x plus 2. And then my second one is going to be subtract 4x. So 6y equals negative 4x plus 12. Divided by 6, divide by 6, so y equals negative 2/3 x plus 2. So I'm going to graph the red one first, which is plus 2. And then I can do a rise of negative 2, run of 3. Rise of negative 2, run of 3. Rise of negative 2, run of 3. I'm going to graph that. But if you notice, the blue equation is the exact same one as the red equation, so I would be graphing that blue one right on top because they're the same line. So where do they intersect? They intersect everywhere because they're the same exact line. So that means, so they're the same line. They intersect everywhere. So they have infinitely, ooh, I just spelled that wrong. Infinitely many solutions. There you go. So it intersects at all the points on the line. Infinitely many solutions. All points on the line. We'll write that later. Okay, so this kind of concludes that for system of equations, we have 3 options, okay? They are going to intersect at a point, so they're going to intersect at one point. We saw that at the beginning. So they're just going to cross at one point, and then that means you only have one solution. You might have where they don't intersect. That means don't intersect. That means that they are parallel lines. They'll never cross. And then you also have intersect at all points, which means that they are the same line. There you have it.